Hey everyone, welcome back to this channel. In today's video, we are diving into one of the fundamental concepts of operating systems, processes and threads. These two components are essential for multitasking and efficient resource management in any computer system. If you are new to software engineering or just starting out with operating systems, understanding processes and threads is crucial. So, let's unpack what they are, how they work, and why they matter. To start, let's talk about processes. A process is essentially an instance of a running program. When you launch an application on your computer, be it a web browser or a text editor or a game, your operating system creates a process for that application. This process has its own allocated memory and resources, and it's isolated from other processes on the system. Each process operates independently, which is why if one application crashes, it doesn't necessarily crash your entire system. The operating system manages these processes to ensure that each one gets the resources it needs, like CPU time and memory, without interfering with others. This separation is critical because it keeps your system stable and efficient. The operating system has to be smart about process management. It uses a system called scheduling to decide when and how much time each process gets with the CPU. Since your CPU can only work on one task at a time, the operating system rapidly switches between processes to give the illusion of simultaneous execution. This process is called context switching, and it happens so quickly that we perceive it as multitasking. There are different types of schedulers within the operating system, like the long-term scheduler, which decides which processes are added to the queue, and the short-term scheduler, which actually assigns the CPU time to processes. This scheduling is what makes your computer feel responsive and able to handle multiple applications at once. So, what about threads? Threads are often referred to as the lightweight version of processes. If a process is like a program in execution, then a thread is a smaller unit of that process. You can think of threads as subtasks within process. Each thread within a process shares the same memory and resources but can execute independently. For example, if you open a web browser, each tab might be managed as a separate thread. This means you can have multiple tabs open or running different pages, but they still share the browser's memory and resources. If one tab crashes, it doesn't necessarily crash the entire browser, thanks to thread management. This brings us to the concept of multithreading. Multithreading allows the process to have multiple threads running concurrently, which improves performance by dividing tasks. For example, if you are using a word processor, one thread can be handling the user interface, another could manage autosaving, and another might be running a spell check feature. Multithreading can make applications more efficient and responsive because each thread can handle different tasks independently. This structure is particularly useful in programs that need to perform background tasks without interrupting the main functionality, like autosaving in a word processor or buffering in a video player. However, multithreading isn't always simple. Threads share the same memory, so if multiple threads try to modify the same data at the same time, conflicts can occur. This is called a race condition, and it can lead to unpredictable results. To handle this, operating systems provide synchronization mechanisms like locks and semaphores, which ensures that only one thread can access specific resources at a time. Let's quickly recap the main differences between processes and threads. Number 1. Isolation. Processes are isolated from each other with their own memory and resources, whereas threads share memory within the same process. Number 2. Overhead. Creating a process has more overhead because the operating system has to allocate resources and manage memory for each process separately. Threads are more lightweight and can be created and managed with less resource usage. Number 3. Stability. Since threads share resources within the same process, an error in one thread can potentially impact the entire process. Processes, on the other hand, don't interfere with each other, which makes them more stable. Number 4. Use cases. Processes are ideal for running separate applications, while threads are better suited for tasks that require concurrent actions within the same application. Understanding processes and threads is essential for software engineers because these concepts are the foundation of how applications handle multitasking and resource management. As you move into more complex applications, knowing how to use threads effectively can make your software more efficient and responsive. For example, if you are building a web server, you might use a multi-threaded approach to handle multiple client requests simultaneously, which reduces wait time and improves user experience. On the other hand, for applications that need high stability, using multiple processes might be a better choice to ensure that errors in one part of the application don't bring down the entire system. Processes and threads are key components that enable multitasking on modern operating systems. While processes keep applications isolated and stable, threads allow for concurrent execution within the same application, making it more efficient. Both are vital for creating smooth, responsive software. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss any future videos. Thanks for watching, and I will see you in the next one, inshallah. Assalamu alaikum.